70 targeting bra 050 40-25.000 διπλή επαφή.
Welcome to another tutorial video from Fighter Pilotex. In this video we're gonna cover some surface attack basic tactics and how to calculate the pop-up parameters manually. And on the last part we're gonna see how to put these parameters and stick diagrams on a map and make your Kneeboard page for executing the attack in DCS. The base of the theoretical background is gonna be a PowerPoint presentation that I used 2 years ago when I was flying with VRAF 7 guys from UK, and I was teaching about these things. Please keep in mind that all these are for entertainment purposes only and not for real life use. The overview of the talk gonna be like this: planning consideration, basic offset pop-up attack, 2-ship pop-up attack tactics, and terms and acronyms. The main question you need to answer before you plan your pop-up attack is why are you doing so? Air-to-surface missions have two basic objectives: target distraction and force survival. That's gonna be our objectives and consideration while planning pop-up attacks. In real-life planning, these are all the factors you need to account while planning for your pop-up or surface attack in general. But here in the DCS, for simplicity, we are gonna deal only with enemy defenses, weather and weaponeering. Here we have an example of variables for these factors. So enemy defenses could be an optical tracking AAA systems, very primitive. The weather should be, if the weather is overcast, for example, that prohibits the use of laser guided bombs, you are left with Mark 82 as for the weaponeering and the target distraction, and mission objective is mobility kill, let's say for a truck or a tank, and of course for survival you need to stay low at all phases of the attack. These are examples of reasons why you should do an offset pop-up attack. Let's establish some ground basic knowledge of what is a pop-up attack and its geometry. The idea is that you need a plan to drive your aircraft in the correct point in space, so to deliver accurately free fall weapon in CCIP or manual dive bomb, and also you can use it with CCRP also if you like. These modes are available in every modern jet: A-10, F-18, F-16, F-15, etc. We have the target with the blue triangle, and we have the jet that it's depicted on the left. First thing you need to do is to connect an imaginary line between your target and the aircraft, and this is from this point onward we're gonna draw the stick diagram. We have the face of ingress, which you are going low and fast. At the action point you need to offset in either side for the designated angle during the planning. At some point you need to pull up for the desired Gs per aircraft, 4 to 5 for F-16, 2.5 to 3 for A-10 for example. You climb for the roll-in point, which will be very specific and calculated during the planning. Then you need to aim for your target by putting back angle and pulling down your lift vector towards the target, the blue triangle, in order to get to the tracking point where your aiming phase starts and your tracking time start counting. In order to put the aim of distance or the aim of point long of the target usually, drop your weapons at the pickle point at a specific altitude, and then egress safely from weapons defenses and looking for visual mutual support. The purpose for this maneuver is to get your aircraft at the beginning of your aiming, this called the tracking point. So you will climb down the dive angle in order to reach the release altitude where the aircraft should solve the attack, the bombing triangle. A7 was the first aircraft that had CCIP and could utilize a mission computer in order to do all this difficult calculation to execute the bombing accurately. Before that, we did the same exact maneuvers, but we need to solve the bombing triangle by ourselves. So we do a pop-up attack in order to help the mission computer solve the triangle. Here is an example of a stick diagram. Here you can see the dive bombing 30 degrees, release speed 480, 5G's climb for F-16. This is the attack triangle with the altitudes of actions. We have a ripple of 6 Mark 82 low drag general purpose bombs, fusing nose, tail and interval 50 feet. As you can see here, we have the IP south of the target. We have the climb safe escape maneuver after the release, denoted with the dotted red line. Climb safe escape maneuver. So here is an example of this attack as it was done by me with an F-16 at the Caucasus map. We are looking for 5 nautical miles on the HUD. I'm executing this attack using the green stuff on the HUD, so I'm going by distance. Other 2 ways to do this attack is by counting seconds from the IP or by landmarks on the ground for each action point. So I need to go 15 degrees right on the action point. I'm doing 285 now with 540, okay, 10 right for 300 degrees, 3.9, pull up 4 to 5 Gs for 30 degrees nose high, looking left side for the target and for the altitude for the roll-in. The rule of thumb is that you need to start rolling 200 feet before the roll-in altitude written on the attack triangle in order to be exactly at 6.3. If you notice here, I was a little bit late. Dive angle, aim of distance, the vehicles are the target, pickle and hold, and I didn't do climb safe escape here. I did a turning maneuver level turn. Here is the same exact attack as it is seen from the TAC view. So with this image video, we would like to compare what it is drawn in the left with the actual ground track of the aircraft on the actual map. You will see that is quite similar. Offsetting 300 degrees, pulling up 3.9, looking for rolling altitude. I will say again, the calculated rolling altitude, you need to lead on this altitude by 200 feet when you are executing the attack. So you will be exactly on the correct apex. Somebody's tried to shoot us there, no luck. Release. When you have to do this attack with 2 aircraft, you need to take into account deconfliction of the flight paths. Methods for deconfliction is by altitude, by space and by time. The second reason for deconflicting the 2 aircraft is the fragmentation of the bomb of the first aircraft. A Mark 82 will have fragments traveling from the ground upwards up to 2,500 feet for 25 seconds. Here is an example of an echelon attack, both aircraft deviating right, but the left aircraft has a drop point 3.5 thousand feet and the right aircraft 5,000 feet. Although the pop-up point for 2 aircraft is from different distance from the target, it will be almost simultaneously because the aircraft already flying 1 mile line abreast. Here we have a time deconfliction example where the orange aircraft on the right will do an arc around the target, and with this time deconfliction both aircraft can execute the same attack parameters with the same attack triangle 5.1 roll-in, 6.3 apex, and delivery at 3.5. Here is a space altitude example. Split attack, one aircraft goes left, the other aircraft goes right for space deconfliction, and also we have altitude deconfliction because one aircraft releases 3.5 thousand and the other 5,000. This is the famous double 90 or trap attack invented by the Israelis during the 6 Days War back in 1967, if I am correct. The rookie aircraft, the novice airman on the formation, do the orange track while he's been observed from the leader, more experienced, by doing 290 turns and then attacking with the same parameters exactly. And now some terms and acronyms. High, medium, low apex has to do with the maximum altitude climbing. Low apex up to 3000 feet, 3 to 6, 7 medium, above 7, 8 high. F kill means firepower kill, M kill means mobility kill, K kill means catastrophic kill. Everybody I think knows the DIMPI, desired mean point of impact. One critical parameter during the planning phase will be the minimum attack perimeter, where the tracking phase starts, actually at the tracking point, and we have the three separate recovery maneuvers: turning maneuver, maneuver level turn, and climb safe escape maneuver. Before we proceed to the next part, let's review what we did. Planning consideration, remember, are the factors. Why we do offset pop-up attacks, easy visual on targets. Remember, with two ship to deconflict, and essential acronyms for brevity and clear, precise communication. Moving on, in the manual calculation of the parameters, on the left you can see a manual pop-up planning list, which gonna be populated by first deciding what kind of weapons we are going to use as per desired target, and for this reason first we need to establish an example so it will be easier for you to understand the chain of events. So let's say, for example, we would like to do a small interdiction in the airport of Getikale, on the north and east part of Cyprus, which is a runway extending from east to west. Here is from the mission editor the image, and here is the DCS image. And let's say we have to plan for two aircraft, one hitting this part and the other hitting the other part. So we would like to cut the runway into points, as it was shown by the moving purple arrow. We would like to pick an IP point at the south part of Cyprus, so it will be a point down to the coast. Moving up north for the attack, let's go for a split attack, one aircraft left, one aircraft right to each point. And here starts the planning. First we need to decide a weapon. Let's go for 6 times Mark 82. We don't give consideration for the impact angle of the bombs. We just like to make some craters that will take about 1 to 2 hours to be fixed in the airport. So we would like for this attack to deny the use of this airstrip for, let's say, 2 hours. So Mach 82, we need at least one bomb on each side of the runway. That's why we are dropping a string of 6 for multiplying the possibilities of hitting at least one bomb on the pavement. Having decided the weapons, you need to find the bomb range from the ballistic tables. Here is an example of some tables I found from an F5-34 ballistic manual, which I found it online, so you can find it also if you search correctly. We are gonna scroll down this document in order to find 5 or 6, whatever suits us, for Mark 82. Almost same ballistic as Mark 83. and let's see if this table suits us. We are looking for the angle in degrees, first column, release speed, the second column, and the 1, 2, 3, 4, 1, 2, 3, 4. The fifth column from the left is what we are looking for, which is the bomb range from the center of the pattern, the center of the stick. The best data I could find in this manual was this for 5 times Mark 82. So actually we are planning for Mark 82, not Mark 83. And for 15 degrees and 480 speed, I'm starting populating, so speed 480. True or calibrated at low altitude are the same. I'm working on this row, dive angle 15 degrees for small exposure. Small impact angle, and I'm working on these parameters here. So I'm looking for the bomb range that goes here, which is 3,916 feet. So I put this number there at step 4, and next gonna be the dive, the release altitude 1500 feet. Next thing I need to decide is the tracking time. An experienced pilot could go with 3 seconds aiming tracking time. An inexperienced pilot should go 5 or above. So for this attack, let's pick 5 seconds for tracking time, and we put this number there because it matters for the planning. Next thing is we need to calculate, and the calculation starts here. We need to find the slant range we travel during the aiming, during the tracking time, so we are using the formula I just showed. When we say slant range, we are talking about the hypotenuse of this right angle triangle, as you already know. So by executing this formula here, you get the altitude for the result for the slant range. So the result is 4,056 feet, and you're moving downwards, calculating what is written for steps 7, 8, and so on. Next is, now that you know the slant range, to calculate how much altitude are you going to lose during this tracking phase. You use the formula on step 7, which uses the sine, trigonometric function of sine of 15 degrees, which is the dive angle. You round to the best number, so 1050 feet. On step 8, you need to calculate the ground distance for the same triangle you are traveling, using the cosine of 15 degrees. Use a scientific calculator and get your result. If you are good on Excel, you can do an Excel formula that calculates all this automatically. If you do so, please share with us. On step 9, you need to calculate the minimum attack perimeter, which is, as you can see below this line, bomb range plus ground distance covered during the tracking phase. Bomb range is 3,916 feet we took from the table, plus the 3,900 lost during the tracking gives us 7,800 feet. This is the map distance, the ground distance from the target. And now we need to calculate the map altitude. First, it's a good idea always to convert the map distance into nautical miles by dividing with 6,050. So that gives us 1.3 nautical miles. And let's move on to step 10. which will calculate the altitude we should be at the beginning of our tracking point or aiming phase. Use the formula below, so we have release altitude plus altitude lost during tracking. Do this addition and get your result, which will be 2,550 feet. On step 11, you need to get the 10 radius from a table. I couldn't manage to find declassified such tables, so I use my memory, and let's say 4,000 feet 10 radius for an F-16 turning on sea level with 4.5 to 5 Gs. If you can find some better numbers, use it there. Remember to use the table correctly. Let's move on step 12, which calculates the apex altitude. For F-16, F-18, F-15 go with the lower formula, 4.5 to 5 Gs roll-in. If you are planning this for F5, A4 or A10, use 3 to 3.5 Gs for the roll-in, and by using the formula you will get the map altitude. You will get the apex altitude, which for this example is 3,100 feet. Subtract from this altitude 37.5 times the dive angle, and you get the rolling altitude, the point where you start rolling and then pulling towards the target. The result is 2,500. For now, we are going to skip steps 14 and 15 because we first need to put what we have calculated on the map for the mission editor and the Kneeboard page. Moving on to the Kneeboard, to the mission editor on DCS with our target, we're gonna use the following tricks in order to put this with drawings on the map. First, you need to mark the DIMPs for each aircraft using the drawing feature, and then you need to put the map distance 7,800 feet on the same map. And the trick for doing this arc is by using the trigger zone function, where I make the trigger zone according to my radius 7,800 feet, and then I draw over, superimpose on the arcs of my desire in order to have the correct map distance for this attack I am planning on. I'm using the segments line in order to draw over the perimeter of the trigger zone that you can see. This is for the left aircraft, and I do the same for the right aircraft, an arc on the right side of the trigger zone perimeter, which is actually our minimum attack perimeter. Then I move the center of the trigger zone on the DIMP for the left aircraft, and then I move over the arc of the map for the left aircraft. Don't use the white box because it will mess up your drawing. Use another spot on the arc to move it. And now we have the map for the left aircraft. By using the same trick, move the center of the trigger zone to the blue DIMP, you get to move the perimeter for the right aircraft to the correct position. Move it there, then select drawing, and now you have your minimum attack perimeters arcs at the correct position for each aircraft. In the next step, we're gonna set the attack direction for the left aircraft. If we have an elongated target like a runway, we need to have an attack axis of about 10 to 20 degrees different from the axis of the long target, so you get a result of attack direction like this. Next thing to do is to shorten this line connecting the map with the DMP according to the ground distance covered during the tracking phase. So I need to go back to my planning list to get the number or the length from the map point to the release point. It is not what I'm showing here, is the number 3900 feet, which is actually the ground distance covered. And because the angle is too shallow, 15 degrees only, it's almost equal to the other number I was showing in the slide. As you have already understand, we work from the DMP and outworks, so the next thing to do is to draw the ground track from the roll-in up to the pull-down. In order to do so, we are gonna draw in this God's eye view our turn radius, which, as I said in the planning, it was about 4,000 feet. So again, by using the trick of the round trigger zone, I will superimpose a circle with this radio over this new smaller 4,000 feet radius trigger zone in order to have a circle depicting my turn radius for the roll-in apex pull-down phase in order to draw this accurately on the map of the attack or the stick diagram. So I superimpose the perimeter. I could use the circle tool, but I do it by hand using the segment tool. And after I complete it, I will rename it as turn radius because I'm gonna use it later on for the attack of number 2, also for the egress phase turning maneuver level turn. I will zoom out now and I'm gonna put this trigger, this turn radius circle tangential to my attack axis. I do this using my eyeballs, no specific measurements there. So I will drag this circle and put it in a tangent way to the attack axis, so I can draw by going outwards from the map point all the way counterclockwise until, let's say, 1/4 of the perimeter. I zoom in to have a better accuracy, and using the segments line, plural, I draw what I want to be drawn there, depicting the maneuver from the roll-in apex pull-down up to the initiation of the tracking time period. I do a small adjustment. Okay, I rename it because I would like to use it later probably. I fix this thing over there on the top, and that's how you design this thing. I move it to do the same on the other side. I just leave it there to use it for the number 2 aircraft on the right doing the same thing. So now that I have finished my maneuver from the roll-in to the target, I need to decide where the IP will be. It should be in the southern part of Cyprus, so I need to connect the initiation of the roll-in with the ingress route, and in order to do so, I will draw a line from my target to the IP. It's a good idea to look for an IP from 20 to 25 miles from the target. I cannot do this here due to the short distance between the south coast and my target. Usually when using an IP, it's an intersection of roads, it's something distinguishable on the ground, a landmark that you can see while flying low and fast from your jet. I will pick, let's say, this intersection here, and I will draw a box over it depicting the initial point or IP. Now that I have decided on the IP, I'm going to connect the IP with the sender between my DIMPs, because both aircraft flying line abreast are going to use the same general ingress direction up to the action point where each aircraft will split left and right for their attack. So again, with a draw feature, segment the center of the runway, connect it with the IP. I would like to be as precise as I can. I zoom in, I adjust the direction of the line directly from the IP to the center of the runway, like this, and then I will connect this point here with the line I have just drawn in order to have my ground track after the action. The preferred angle off from the ingress direction is about 20 degrees, so I will roughly connect it like this. That, as you're gonna see later on, it's gonna give me a deviation of 23 degrees from the ingress direction. Okay, as accurate as I can do. And now we have almost finished the ground track. Now it's time to put the tick marks. This tick mark here is for the rolling point, where I should add some information later on. And now in this direction I need to find out the pull-up point. In order to do so, I need to go back to my planning list to find the number I need, which is not calculated yet. So first I need to decide on the climb angle. I will do this with the first formula, dive angle plus 5 degrees, because I'm doing a dive of 15 degrees dive angle. So that means I need a climb angle of 20 degrees at a specific point. And in order to find this specific point, I need to do it manually by using a right angle triangle, such this one, where I solve for the distance x, which gives 6,868 feet, which is the distance I'm going to depict here by putting a tick mark at the desired pull-up point. So using the ruler, I draw this distance. This distance is a little bit bigger than 1 nautical mile, so I will calculate it with 6,050 feet, and it gets about 1.14 nautical miles, which this is the distance from the rolling point where I will put my tick mark, like this. And the next tick mark I'm going to put is on the action point, but first I need to measure the distance between the action point and the center of my DMPs, because I would like to use this distance from the center of the target when I'm doing this attack using the HUD information. So, knowing the distance, I'm putting the tick mark here, and the relevant information will be put there later using a text box. Here is the action distance. Now I need to put how many degrees left I'm gonna deviate in the action point. So I'm using the ruler to find out the angle of direction. I subtract it from the ingress direction, and that will give me 23 degrees that I'm going to add in the info on the action point. Having do so, I will repeat the same text box technique on putting the relevant information on each tick mark that I have put in my stick diagram. This is the pull-up point, and the next one over that is the roll-in point. But first I need to measure the distance between the center of the targets and the pull-up point, because this is another piece of information I would like to use during my attack using the HUD information. So using the ruler I get the distance, which is 2.6 nautical miles. The text box for the pull-up point is ready. Now I need to write the text box for the rolling point. So I need to get back to my calculation to gather the information I need to put there. Rolling altitude 2500 feet, and again with the text box feature I add this information to the rolling point tick mark, like this. Next thing I need to do is to draw my side view triangle with the altitudes, again with a draw feature, segments or segment. I complete the attack triangle. Now I need to brush it up a little bit, so I don't need this part of the ingress line. I'm going to shorten it like this. And now in this point here I'm gonna add the direction of the ingress along with the desired speed. And what it's yet needed here is to draw the climb out maneuver or the climb safe escape maneuver or the turning maneuver level turn. In order to do so, I will use again the turn radius purple circle. What kind of color is that? I don't know exactly in English. So I will put this circle tangential to my attack axis at the release point, at which point I will use red ink to draw with dotted lines the egress maneuver of the jet of the left aircraft. Now that this thing is done and I have put with a text box the relevant information, turning maneuver right for a heading 174 degrees. You have noticed that already I have adjusted the thickness of the lines and the size of the letters in order to go to my final step of producing my Kneeboard page. In order to do so, I will use the snip tool on the windows, and I will take a rough rectangular of about 1.33 ratio 4:3. I will copy that selection and I will paste it on Paint. Or you can save it for later use, so I use copy. Then I open Paint. Everybody has Paint in their computer. I just paste it there. On the bottom side below the picture you can see the size, the resolution. It's almost correct, 1024 by 768, almost there. That means it will have a good representation on my Kneeboard page while flying the attack. Remember to save this with the appropriate name in the appropriate folder for the aircraft you are flying this attack. And now it's time to feel happy for yourself that had the patience to follow all these complicated instructions to do so. The major advantage of depicting your attacks like this is that you are doing this in the real map, so it will be easy to do the attack even without the green stuff on the hand. And having said so, if you follow this ground track from the IP towards the target and you study the map, you will see that your IP is a distinguishable point on the ground. Going in direction 354, pass a road, you see the small lake, and just before the next road is your action point. Turn left 23 degrees and go low after this road, and just before the stream of this river you're pulling up for your target. You look for your target on the right and off you go. Thank you for staying so far at this long video. Try this out, and if you have any observation, please comment on this video.